Okay, so we start part 2 of this chapter. It is about arithmetic between rational functions. So first, let's look at these two keywords. Arithmetic means addition, subtraction, multiplication, and division. So basically, we are trying to combine different rational functions. Okay, so what are rational functions? Now, you know about rational numbers. Rational numbers, they are fraction of integers. You have integer, right? 6 and 7, for example. You put them in a fraction. So this is a rational number. So rational functions, they are fraction of polynomials. On top, it is a polynomial x squared plus x minus 2, for example, right? On the bottom, there's another polynomial x plus 3 and so on. All right, so these are called rational functions. So in principle, we are doing this chapter just like what we did when we learned about the arithmetic between fractions. Okay, so we learned that in primary school. So let's take a look at this one. Very simple. Primary school, we do something like this: 1/3 plus 1/2. All right. So to do that, first we get the LCM between 3 and 2, and that would be a 6. All right. So we change 1/3, we change it to 2/6. 1/2, we change it to 3/6. All right. With the common denominator, we can add the numerator together. All right. The bottom is the same, so it's kept. The top, you just add them together, so it is 5/6, right? Primary school stuff. But now we are doing something like this. Say we have 1/x is a polynomial, 1/y, y is another polynomial in y. All right. So we want to combine them together. So once again, we pick out what is the LCM between x and y. That would be x times y. That would be their LCM. All right. So 1/x is now changed to y over x and y, isn't it? And 1/y will be changed to x over x and y. Alright? Alright. So now we follow the similar step. We have the common denominator x and y, while on top we have y plus x. So this is it. This is how we add two rational functions together, just like what we do on integer fractions. Alright. Okay, let's take another example. 1/x and 1/x plus 1, for example. Alright, so once again, you have to think about what is the common denominator between the two fractions. Right? Usually, it is taken as the LCM. X times x plus 1 is the LCM. Alright, and the first one will be x plus 1. Alright, this actually is this one. Is this one. Alright, and the second one will be x over x plus 1. X over x times x plus 1, right? So combine them together, right? The denominator, you don't have to repeat 2 times, right? Just once. While on top, it becomes 2x plus 1, right? So it's like that. Alright, when we turn to subtraction, for example, let's take a look at more. I try to present these examples in increasing difficulty, right? This one is the more complicated one. 3x over x minus 3, subtract 12x minus 18, and that is divided by x squared and minus 6x, x squared minus 6x and 9. Alright, we try to combine this. Now, first of all, you have to think about what shall be the LCM between the two denominators, x minus 3 and x squared minus 6x and 9. Alright, of course, it's not a difficult one. You can see that this x squared minus 6x and 9, this one actually is x minus 3 all square. Alright, once you can break this, the common denominator is not difficult. Alright, so it shall be x minus 3 all square. Alright, and then the top part will be 3x times x minus 3 times x minus 3, and the second one will be minus 12x minus 18. Alright, now but by writing this, I made a mistake. Now it's a very important thing. It's a very common mistake that actually one of the bracket was omitted there. Alright, actually it should be put in the bracket like this. Alright, so when you do the subtraction, the bracket shall be here. It is minus, inside the bracket, 12x minus 18. Alright, so once you simplify the numerator, it shall be 3x squared minus 21x plus 18. Alright, and it is divided by x minus 3 all square. Alright. Of course, if you want to, you can further factorize the top part. The top part will be 3 times x minus 1, x minus 6, divided by x minus 3 squared. Now, that is the simplest form, alright, for this result. So, I would make a footnote here to remind you the common mistakes of dealing with negative sign and the brackets, alright. Now, sometimes you'll be able to do that, like when you have 2 minus x plus 1, right? So you know that should be 2 minus x minus 1 instead of plus 1, this one. Alright. But sometimes the bracket here is omitted. Say for example you have 2 minus x plus 1 divided by 3. Alright. Now you can't see the bracket. The bracket can be omitted. Right? With the bracket it's like this. But it is the same without the bracket. It's so easy to make the mistakes by breaking it into 2 minus x over 3 plus 1 over 3. Now this is a very common mistake when people are dealing with subtraction and then a bracket. Alright, please be very careful. This one shall be a negative instead because of a understood bracket for this x minus plus 1 divided by 3. Alright, so this is the end of the first part of the video. It's about addition and subtraction between rational functions. Right? We do it in a similar way to that we do it for integer fractions. All right, we get a common denominator and then we try to simplify the numerator. All right, and please take the note at the bracket and the subtraction. All right, so this is the end of the first part. We have a second part to follow.